Day 45 of the Capital Markets House, and Danielle has been called to the diary room to face an unexpected task. Should she fail, she will face the public vote to be eliminated immediately from the house without saying her goodbyes to her fellow housemates. Hello, Danielle.
Hello.
Happy Halloween. Sorry for dragging you away from the Halloween party. Nice to see you've dressed for the occasion. Here's hoping you aren't in a joking mood, as I have a series of general knowledge questions and tasks for you. If you fail, you will face the public vote. Your first general knowledge question: which is the largest ocean in the world?
The Pacific?
Your first task centres around optimal portfolio choice. On the sheet provided on the chair, it should read as follows: two securities with expected returns 0.03 and 0.08, variance 0.02 and 0.05, and covariance minus 0.01. Plot a graph with the set of feasible mean variance combinations of return, assuming that the two securities are the only investment vehicles available to you. Good luck, Danielle.
Thank you. Okay. So judging from the information you've given me, I already know the expected return of the portfolio assets. So I am able to draw the y-axis as the expected return and the x-axis as the risk associated with the portfolio. However, you've given me the expected return, so I can go ahead and plot that straight away. 0.03 for the security 1, 0.08 for security 2, and you've given me the variances of both securities. So in order to be able to plot these accurately on the graph, I'm going to find the standard deviation of each, which I find to be 0.141 for security 1 and 0.223 for security 2. I'm now able to plot the points in the graph that correspond to the risk and the return associated with each security. But in order to figure out how the graph should actually look, I need to work out the correlation coefficient. Is the graph going to demonstrate a line, or is it going to be a curve? So to do this, I use the equation. Correlation coefficient is equal to the covariance of xy all over the standard deviation of x upon the standard deviation of y, which from the information you've given me, I know that the covariance is equal to minus 0.01 all over the standard deviation of x, which I found to be 0.141, and the standard deviation of y, which is 0.223. So calculating this, I can find that the correlation coefficient is equal to minus 0.318. So from this we can see that the trade-off between the risk and return is actually negatively correlated. It's not perfectly negatively correlated, or else we would have got a figure of minus 1. So I'm now able to draw the graph as follows.
Okay, Danielle, your second general knowledge question. What is the largest island in the world?
Ireland?
That was an easy one. We'll stick with the task. Task 2 is to minimise risk. How much of our portfolio should we invest in security 1? Extra paper has been provided to you beside the chair.
Okay, so in order to find the minimum risk portfolio, I know that we use the variable A, which I assume to be equal to the variance of y minus the covariance of xy all over the variance of x plus the variance of y minus 2 times the covariance of xy. So from the variables you've given me, I'm able to put these into the equation, and I can get the following: 0.05 minus minus 0.01 all over 0.02 plus 0.05 minus 2 times minus 0.01. So putting this into my calculator, I can find the value to be equal to 0.667. For me, this indicates that approximately 66.7% of the portfolio should be invested in Security 1, therefore approximately 33.3% should relate to Security 2.
Okay, Danielle, as a part B to task 2, where would you think the portfolio should sit on the curve from the graph of task 1?
Okay, so given the fact that the minimum variance portfolio will have the minimum amount of risk given the minimum amount of return, I would assume that this point would lie approximately around here.
Okay, Danielle, for your final general knowledge question, and hopefully you can get this one right, what city is known as a forbidding city?
Amsterdam.
Geography isn't your strong point. Your final part of the task. Find the mean and the standard deviation of a portfolio that is 50% in Security 1.
Okay, so I know that the equation for the expected return per portfolio can be defined as the expected return per portfolio is equal to variable A upon the expected value of expected x, plus B upon the expected y. So judging by the variables you've given me, I can actually plug these in as the expected variable of x equal to 0.03 and the expected variable y equal to 0.08. The variables a and b I can define as equal to 0.05, given that half the value is going to be in each. So I can put this in as my values a and b. So working this out, we get a value of 0.055. In terms of the variance associated with portfolio, we can define the variance as the variance of the portfolio is equal to a squared upon the variance of x plus b squared upon the variance of y minus 2ab covariance of xy. So again, using the variables we've given and based on the assumption that a and b will be 0.5 given the split of the portfolio, we can plot this in as 0.5 squared upon 0.02 plus 0.5 squared upon 0.05 minus 2 times 0.05 upon 0.05 times by minus 0.01. Working this out, we get a value of the variance of the portfolio is equal to 0.0225.
That was good, Danielle. You may rejoin the party, and the cabin master will get back to you